Okay, 10.2, inverse of a function. So what an inverse is the kind of two functions that sort of do and undo each other. And so an example would be, say I have 5 squared square root. So the 2 squares the 5, right? And makes it a 25. But then the square root takes it right back to being a 5. So that'd be an example of inverse functions. And so that's kind of what this section is about. These steps for finding the inverse I'll come back to when I'm actually doing it. The notation, let me write that a little bit bigger. So f has a little -1 of x. That's read f inverse x. And I have this little note. This is not an exponent, so it has nothing to do with this. This is total not right. So this literally just means inverse, the word inverse. It's an unfortunate notation because it really feels like an exponent, but is not. So first I'm going to go through kind of 3 ways of looking at an inverse. If we were given a table like this, the inverse would be it's the reverse of the x and y's. So if the original function has 0, -3, the inverse has to have -3, 0. Because then, again, they kind of do and then undo each other. 1, 1, so that's still 1, 1. 2, 5, so that would be 5, 2. So I'll graphically, so that's our second way of looking at it. I'll graph both of these, and you'll see there's a certain symmetry between a function and its inverse. So when x is 0, y is -3. When x is 1, y is 1. And when x is 2, y is 5. So that looks kind of like this. And then the inverse, so when x is -3, y is 0. When x is 1, y is 1. And when x is 5, y is 2. There we go. And so the symmetry that we see between a function and its inverse is if I folded this diagonally, and I'll sketch a little line here. So the function is always equal distance from that line, so that's its line of symmetry is about the origin. Oops, one more, sorry. So our third way of looking at it is algebraic. So the function we've been working with is f of x equals 4x minus 3. So if I was asked to find f inverse x, the first thing I would do is ditch f of x and call it y. And then this goes back to the steps. So the first step is replace f of x with y. The second step is swap the x or x's for y, and then solve for y. So second step, swap x and y, and it's the same thing here, right? The points are swapped. So since the x's and y's swap in the table, the x's and y's for the inverse have to be swapped in the equation. But now this isn't a function of x anymore, so that's that third step where we solve for y. So I'll bring the 3 over, and then I'll divide out the 4. And so I'll write that over here a little bit better. So actually we'll go right here with it. That means y equals, and what this y equals is f inverse x, and it's x plus 3 over 4. So that's kind of my answer. Remember, we kind of invented the y, so we should probably be saying f inverse x, but this is easier to solve with. In terms of the graph, if you check it out, so this would be in slope-intercept form, y equals 1/4 x plus 3/4. So the inverse, the black line, should be going through 3/4 and have a slope of 1/4. So that looks about like 3/4 right there, over 4 and up 1. So those are our inverse functions. Okay, so this is kind of putting all that together into one problem. So we're supposed to find the inverse and then graph the original function and the inverse. So I replaced f of x with y, and then I swap my, I swap my x's and y's, and I solve for y. So I'll subtract the 1 over, and I get x minus 1 equals 1/3 y. And then the best way to get rid of that 1/3 is to multiply by 3. So that'll be 3x minus 3 equals y, or f inverse x. So that's the first thing we're supposed to find. And then I'm supposed to graph both of these. So I'm just going to write this in kind of the better order here. So there's the inverse. So if this is the inverse, if x is 0, then y is going to be negative 3. If x is 1, y would be 0. If I wanted a third point to make sure I did this right, I could do 2. Then y would be, this would be 6 minus 3, which would be 3. So once I have those, and this one is f inverse x. When x is 0, y is negative 3. When x is 1, y is 0. And when x is 2, y is 3. So then for this one, and I picked this one to plug into because it didn't have the fraction. But so for this one, for the original, then I just reverse the points. Negative 3, 0, 0, 1, and 3, 2. So when x is negative 3, y is 0. When x is 0, y is 1, and then 3, 2. And we're seeing kind of that same symmetry along the line y equals x. Okay, so this one, so we'll replace the f of x with a y, and then this will be x, and then these are going to be the y's. And this one we don't have to graph, at least not this quarter. We don't see these graphs till 102 or 141. So now I have to solve this for y, which is a little bit tricky because there's 2 y's. So the first thing I definitely want to do is clear the fraction. So now I can go x times y, x times negative 1, and 3y plus 1. Okay, so the trick to this next step is you get all those things with y on one side, everything else to the other side. So I'm going to go and subtract this 3y over, and I'm going to add the x over. So xy, subtracting the 3y over makes minus 3y over here, and I'm adding this x to this side, so x plus 1. And then here's the sneaky step. All you have to do is factor out the y, and then you'll be able to see how to divide it. If you start trying to solve for the one y or the other, you'll mess up the other one, and you just kind of keep cycling around. So you got to do that little factor trick. And then from there, I'll just divide out the x minus 3. And so then I have f inverse x equals x plus 1, x minus 3. Okay, these next 3 are the matched problems. So I'll go a little bit quicker through these. So I'm just going to go, this is going to be x equals negative 2y plus 4, and then we'll solve for y. So subtract the 4 over, x minus 4 equals negative 2y, and then we have to divide out the negative 2 on both sides. And so we get f inverse x equals x minus 4 over negative 2. That's one form of the answer. The negative 2 downstairs isn't great. We could write it in slope-intercept. We could also multiply the top and bottom by negative 1 and get negative x plus 4 over 2. And that's likely the answer that'd be in the back of the book. I think the computer takes that version too, but anyhow, this is what we'd have. So this one looks a little ugly to graph, so let's do this one. So y equals negative 2x plus 4 So we'll do xy when x is 0, y is 4. And how about when x is 1, y is 2? So when x is 0, we have 4, and then 1, 2. And then to do the inverse, I'm just going to, instead of trying to plug in there, I'm just going to flip this table. So 4, 0, 2, 1. So 4, 0, and then x is 2, y is 1. And so it's that same symmetry, it looks a little bit different this time because of the orientation of the graphs. But so if I fold that over, it does still sit right on top of itself. Okay, so this one will jump to swap in the x and y. So I'm just going to make it x equals y plus 7 over 5. This one isn't quite as hard as that one that I did a moment ago because there's only one y. So we'll multiply both sides by 5. And now we have 5x equals y plus 7. And then just subtract the 7 over. So 5x minus 7 equals y, or f inverse x. Okay, and this is one that's a little bit tricky. So this is going to be x now, and then those x's are going to be y's. So then I multiply both sides by the denominator, clear the fraction. And so now I got x times 5y plus x, and then 3y plus 2. So I'm going to bring this over, and then I'm going to subtract this over also. And now I have a common factor of y, so I can bring that out front. 5x minus 3. And then I just have to divide that over. And then that equals our f inverse x.